With our application agents configured and deployed, and maybe some business transactions configured and capturing data in the controller, now's a good time to start thinking about how to troubleshoot with AppDynamics. Thankfully, troubleshooting with AppDynamics is a relatively straightforward and easy process designed to give you the root cause of performance degradation in as few clicks as possible. With AppDynamics, it's very easy to follow the red or follow the yellow in this case to understand which components may be suffering from performance-based issues. We should always keep in mind the time range up in the top right and the scope, in this case, the application dashboard that we're looking at when troubleshooting, as issues can occur on various components or business transactions and can occur at various times, maybe even a few days in the past. From the main application dashboard, it's easy to follow the red, or in this case, the yellow, to see that the fraud detection tier has one node which may have suffered a health rule violation in a warning state at some point in the last 4 hours. Single clicking on that tier can give us a list of nodes, in this case, the fraud detection node that is suffering, and we can double click on this item to go down into the node level dashboard. Another example is this API services tier, which has one, or actually two, critical health rule violations. Here we can see which nodes are affected, nodes 4 and node 7. Clicking on that node brings up the health rule violations that may have occurred over the last 4 hours. When we drill down into a health rule violation, we're presented with a series of information. In this case, this is a CPU utilization too high violation. It affected node 4, and we are presented with a timeline of events. In this case, the health rule violation started at 7:36, and it started because, as we can see in the summary, the CPU busy percent was recorded at 29, which was greater than the threshold that was set of 25% for the last 10 minutes. Finally, with a health rule violation, we can also see how long the violation was in effect for 10 minutes, and the overall violation duration, 14 minutes. That was a relatively straightforward violation. Let's see if we can find one a little more interesting. Here we have a business transaction violation. Here we can see the timeline of events has some more events, in this case, an upgraded status, where our average response time rose from 1969 milliseconds all the way up to 2581 milliseconds, which was far greater than the baseline calculated value of 771. From our main dashboard, we can also see node health violations, business transaction health violations, and all health rule violations. We can also see our overall business transaction health and our overall node health, which will show us violations for the underlying infrastructure and violations for all BTs, respectively. Let's say, instead of proactively monitoring, we knew where an issue was occurring. If you know which business transaction is affected, it's very easy to troubleshoot with AppDynamics. In this case, let's use the make deposit business transaction as an example. Here, I can go down into transaction snapshots to get a listing of snapshots that AppDynamics collected because the requests were either slow or very slow, stalled, errored, or even periodically captured. I've sorted on user experience by very slow, and let's take a look at one transaction snapshot that seemed to take 27 seconds to execute. When you open a transaction snapshot, you're presented with a flow map for this particular request, as well as the ability to drill down into the various components. Now, thankfully, we don't have to drill down into all of these components because we have a number of clues available to us. Firstly, we can look at the potential issues to understand which calls took the most amount of time. In this case, 27.4 seconds were spent on this API call, make services, or make deposit, from an overall execution time of 27.8 seconds. We can quickly drill down into the call graph just by clicking on the slow call and then clicking drill down into call graph. We can also take a look at the flow map and see that the API services tier handled 27.4 seconds of overall execution time, accounting for 98% of the overall execution. So let's just drill down into there. Here we can see that our web request, that our find big prime method was the actual cause of the 27 seconds. If we were to use the make deposit and drill down into its call graph, we would see that the web request that was made, the one that took 27 seconds, actually allows us to drill down into the downstream call. And this takes us right back to our API services tier where find big prime is the main culprit. Let's say we wanted to analyze a series of snapshots instead of doing them individually. Well, thankfully, we can shift click on a set of transaction snapshots, right click and say identify the most expensive calls, most expensive SQL statements. AppDynamics will analyze these for you, and if we sort by average execution time, we can see that find big prime was actually the main culprit in 7 of these different transactions. Let's say that we want to troubleshoot errors or exceptions. There are a number of ways to get there. If we knew what our context was, if we knew what our business transaction was, we can go into slow calls and errors and see the errors and we can see the transaction snapshots that might have errors by adding a filter. We could also maybe go to errors here in the top to see our error transaction snapshots. Now this might be a bad business transaction example because we don't actually have errors. So let's see if there's another way to get there. Well, we can look at top business transactions and go to top transactions by errors to see which transactions have the most errors and exceptions handled by your application and recorded by AppDynamics. Another way to get there is through the troubleshoot screen. We can go to troubleshoot and errors to get presented with a list of transaction snapshots in which errors or exceptions were handled. Any of these transaction snapshots can be drilled down into to expose a call graph showing the errors that occurred. In this case, it looks like our main exception was a reward not found exception that was handled. We can see that the web API tier, by following the red, is the source of that error. Let's say we were proactively monitoring and we wanted to understand which exceptions were handled the most by our application. Well, on the exceptions tab, you can get a count of which exceptions were handled by our application and on which tier. Here we can see that our log4j fatal messages exception was thrown the most by an overwhelming margin. I can then drill down into the log4j fatal messages to get occurrences of this exception. In this case, we can see that they are of the reward not found, which we just looked at previously. Now, because there's no stack trace for this particular exception, we might not see any stack traces listed here. But other errors in your application may actually contain stack traces. We can try to take a look at one of these to see if there are any stack traces listed, but unfortunately, we don't get that for this error either. Looks like it's just what we see in the summary. Now, the last way that I want to show to troubleshoot within AppDynamics is to make use of our anomaly detection feature. Anomaly detection can be accessed either through the Troubleshoot Violations and Anomalies screen or through Alert and Respond Anomaly Detection. With anomaly detection and automated root cause analysis, we can help you reduce your mean time to resolution for application performance problems. Anomaly detection automatically determines whether every business transaction in your application is performing normally. Automated root cause analysis can help us quickly determine the root cause of problems revealed by anomaly detection. Here we see the list of business transactions that are currently being monitored with our anomaly detection. And on the anomaly screen, we can see if any violations have occurred. Here we see an anomaly detected on the make deposit business transaction. And if we were to drill down, we can of course view the dashboard during that anomaly, and we can see the top suspected causes. In this case, API services. We get some high-level metrics, some KPIs on the suspected cause. And importantly, we give you a list of transaction snapshots taken during this anomaly. With these tools at our disposal, it's easy to see how we can very quickly navigate to the root cause of any issue picked up by AppDynamics. By following the red or the yellow, if we are being proactive, and by managing our time ranges and scopes, it's easy to drill down and find root causes of performance degradation. By analyzing transaction snapshots, either singularly or in bulk, we can determine which classes and methods or maybe services accounted for the most time spent in execution for a particular request. Troubleshooting with AppD is designed to be easy and straightforward and designed to get you to the root cause of any performance degradation with the fewest amount of clicks possible. Thank you for your time, and I hope you guys found this useful.